Hey everyone, we're moving on to chapter 6. So in chapter 6, we're talking about confidence intervals, which is a statistical technique used to estimate a population parameter, like for example, a population mean. So in this section, we're going to use sample statistics to estimate some unknown population mean, which is pretty typical because oftentimes it's impossible to know the population mean because the population is so large. We take a sample and then use those sample statistics to make an estimate. So let's look at an example. In this case study, we have a random sample of 500 smartphone users, and the sample mean was 131.4. We also have an assumed population standard deviation. So that 131.4 is called a point estimate because that's a single value that estimates the population parameter. However, we know that that's probably not accurate, right? It's not going to be the same as the population mean. So it's better if we actually try to find an interval that is likely to capture the population mean. So that's the goal of this section, and that's what the interval, confidence interval is called. Okay. We'll need some tools here. So the first one is the level of confidence. So when we're creating an interval, we're going to have to state how confident we are that your interval contains the population mean. Really, it's a probability. It's a probability that you've captured that population mean. So the higher that confidence level, the more likely you've captured the population mean. When working on homework problems, that value will be given. Now, based on a level of confidence, you're going to find a critical value, which is a z-score. It's a z-score that is associated with that level of confidence. The level of confidence is really just the area under the standard normal distribution between two z-scores, right? So for example, if this is 90%, then I can find my critical values using methods that we used in section 5.3. Now, the nice thing is we'll use a lot of the same confidence intervals over and over. Levels of confidence over and over, these four, right? So this little handy table will save us some time so we don't always have to recalculate these same four values. So use this to look up your critical values for those four, okay? Now, there is a StatCrunch method if it's not in that little table that we can use, right? So that'll be our next little task here. So if the level of confidence is not in that table, here's how we can find it. And we did this in 5.3, but we'll review it here. So if I pull up some StatCrunch, we want a level of the level of confidence is 85%. So I'm just going to open a blank StatCrunch page, and we're going to our normal calculator. So that's under Stat, Calculators, Normal, right? So this looks familiar. Okay, and then I'm going to click the between option, and I'm going to put the confidence level in that area box. Right, so it was 0.85 for this problem, and I compute. Right, so I get two values, but when we talk about the level of the critical value, you can just give the positive one. So 1.4395 is what I would put down for that one. So the notation is Z sub C. Okay, and so all of those in the previous table could be found the same way, right? But it's nice to just have that table for a quick, easy reference sometimes. So, okay, so let's continue. Next thing we'll need is what's called the margin of error. Margin of error is the maximum error of the estimate. It's basically going to be the distance from the middle of your interval, where the sample mean is, to the end point, okay? And there's a nice little formula for it. So we'll be using this formula, and those variables should look familiar, okay? Finally, once we have that margin of error, we're going to construct an interval, which is basically just adding the margin of error and subtracting the margin of error to the sample mean. And we've done it. Okay, so let's try one out with these steps below. You can think of it as a little formula like that if you prefer. Right. Okay, so lots of variables floating around, lots of little steps. So let's do an example, and I think that'll help. Back to that sample. Okay, so first thing we need to know is our variables, right? That 500 is an n. The 131.4 is a sample mean. Remember that? That's x bar. Sample mean is the notation for x bar is the notation for sample mean. And then population standard deviation, sigma. We want a 90% confidence level, that's C, so C is 0.9, okay? So those are the four numbers that are given. I just associate a variable to each one. First thing is I need to find that critical value, and that's based off of the level of confidence of 90%. I can go back to my little table. At 90%, I see that is 1.645, so I'll write that down here. So Z sub C is 1.645, and I'm good. Okay, the next piece is the margin of error. Remember, that's the formula. It's always the ZC times sigma divided by square root of n. And all of those things I know, plug them in. 1.645 times 21.2 divided by square root 500. And there we are. If I calculate that, it says to 2 decimal places, I get 1.56, and I'm good to go. Okay. The next thing to do is now construct the interval. That's the little formula where we take x bar and subtract e, and x bar and add e, and we just put them in parentheses separated by a comma, that interval notation. Notice here a little thing about rounding. Up here we did 2 decimals, down here is 1. So the reason for that is that if we're after a final answer with 1 decimal, one of these intermediate steps, I would want to go more decimals, so 2 or more here. Okay, so now we're going to take our sample mean, 131.4, we're subtracting the 1.56, and then 131.4, we're adding the 1.56. And now my final answer, I'm just going to do that rounding to 1 decimal, and I get 129.8 minutes and 133.0 minutes. So we are 90% confident that we have captured the population mean between those two values. A little bit more on the interpretation of that. So we're done with the confidence interval, we got it. But the next piece is interpreting that confidence interval. Here's what we're really saying when we're 90% confident. Like if we did this study over and over, took a different sample each time, created an interval, what would happen is 90% of those intervals we would actually capture the population mean. 10% we would have an error, we didn't capture it. Right, so this is shown in this little picture here, right? Some of them we capture it, some of them we don't. They're all a little different. Like, let's see, this one didn't capture it because it's, that red dotted line is the mean. But 90% of the time we'll capture it. So that's what we mean by saying 90% confident. And so when we do a final interpretation, a correct statement that can be used is below that diagram. So we could say we are 90% confident. So I always want to start like that. And then that the population mean, this is the key. We're capturing the population mean is between the two values that we just found, which was 129.8 and 133. Okay. So if you ever need to write an interpretation or choose one in my lab, use this method here. Okay, here's a little summary of the steps that we just did. So that's kind of nice just to refer to anytime you're trying to calculate a confidence interval. And then there sure are a lot of variables. So here's just a little summary of all the variables that are floating around. So if you get kind of lost with the variables, you can refer to that summary. Okay, let's continue on. How about another example? So here's one. We're just going to do all the steps on our own. So we've got, I like to write down all my variables. N is 36, right? Random sample of 36 seawater samples. The mean was 23, so that's a sample mean because it's based off of that sample. The C is 0.99, and the standard deviation 6.7, right? And then the first thing I need is the critical value, and this is a 99% confidence level. So I go back up to my little table. 99 is 2.576. Okay, so I capture that from that table. 2.576, memorize it. ZC is 2.576. Next, I want the E, right? And that's that formula. Remember, ZC times sigma divided by square root of n. So 2.576 times 6.7 divided by square root of 36. And let's take this out to 2 decimal places because I want to know my final is 1. So minimum I would want here is 2 decimals. I'm going 2.88 there on that calculation. Okay, so hopefully that calculator, your calculator is giving you the same thing. And then finally, construct your interval. That's this little formula, right? Where we take the sample mean, 23, minus what we just found, 2.88, and then 23 plus 2.88, right? Take that sample mean, add and subtract the margin of error, and then we're going to round that to the final 1 decimal. So that's 20.1 and 25.9. Okay, there's our confidence interval, and we're mostly done. Okay, the last thing is, just practice that interpretation sentence. So how confident are we? We are 99% confident. We are very confident that the population mean, sorry for my bad handwriting, is between what? Those two values, right? 20.9, 20.1 cubic centimeters per cubic meter. I guess I could write that cm cubed per m cubed. Getting sciencey here. And 25.9 cm cubed per m cubed. Okay, so that's the main type of problem. Not too bad. Now, some variations in the problems. The next one, it says, here is the confidence interval. It gives it to you. Can you determine the margin of error and sample mean? Yeah, sure. The sample mean should always be in the middle, right? So I like to get that one first. All we got to do is average the 2 endpoints then. And that will give us the middle, right? So that works out to 13. All right. And then where's the margin of error? Well, the margin of error is always the distance between the middle and either of the 2 endpoints. So what I'll do for that one is I'll just take that middle and I'll subtract the first point. And that will give me the distance between the 2 of them. That's the margin of error. Okay. So another way to say confidence interval is you could say, well, it's 13 plus or minus, an error of 2.5, right? With a margin of error of 2.5. Okay. The last thing we'll do on this video is fold in a little StatCrunch here. There is a StatCrunch feature that can construct an interval. So let's try this one. Where you go is, go back to StatCrunch, go back to our main page, right? We're opening StatCrunch. We're still going to stat, but now we're going to go down to a place we've never been before. It's the ZStat. So see that fourth one down, ZStat? I'm clicking on that. And I have 2 choices, 1 sample or 2 sample. This is just 1 sample. And of these, I'm going to choose with summary. Summary means I have the summary statistics, right? The X bar, the N, sigma. So I know all that. So I'm going to choose summary. And that brings up this window. And I just enter in the data. So the sample mean is 34.7. All these steps are in your StatCrunch guide, by the way. And then the standard deviation 6.8 for that problem. And then the sample size 100. Okay. And then confidence interval. And I got to change it. The default is 95. I got to change it to 90. Okay. So we'll do hypothesis tests later, so make sure you're choosing the second choice now, confidence interval. And then finally, and I kind of like to choose that critical value because sometimes my lab will ask for a critical value, so might as well get it while we do this report. Okay, so I'm going to click compute, and it gives me the lower limit and upper limit there at the end, and the other information, critical value, etc. And I'm done. So that's a nice little way to do confidence intervals in StatCrunch. So I'm going to go write that down, 33.6 to 35.8. 33.6 to 35.8. Okay. And I'm going to stop there for now. In the next video, we'll do a little bit more with StatCrunch with some raw data. And then we'll move on to the next section. Okay, hope that's helpful, and we'll talk to you later. Thanks.